screen one more time. All right. So we want the equation between these 2 points, so the first thing we need is the slope. I was the larger y value first, but whatever floats your boat. So 16 plus 2, technically 18. 4 plus 2 is 6. 18 divided by 6 is 3. So your slope should be 3. And then at this point, this is when you get to pick whichever point makes you happiest. I'm going to use 4 16 and plug that into our y equals mx plus b. So I would have 16, m is 3, x is 4 plus b. 12, subtract 12 from both sides, you would get that b is 4. And so then your equation would be y equals 3x. It's 4. Questions, concerns on the warm-up? Oh, once my laptop gets not angry, we will continue on then. So last time we talked about cost, revenue, and profit functions, and then we started to talk about our supply and demand. So remember, supply and demand are essentially the amount that the manufacturers are willing to give you and the amount that consumers are going to buy, depending on which one you're talking about. Also, supply and demand curves always relate price and quantity. So sometimes, especially on your homework, you might have seen this already, that it'll say something like find the demand equation in terms of quantity, or find the demand as a function of quantity, or something like that. So if it wanted a function of quantity, the quantity would be essentially your x values, but then the other value, the y, would be price. And you always want to kind of keep that in your the back of your head, where these are always relating price and quantity. So we finished this first part of this question down here, where essentially, so let me go over it really quickly again. So we have the supply and demand curves for this situation are given to us, and we wanted to know at the price of 10 whether or not we would drive the prices up or down. So when we found both of the demand and supply in terms of 10, we found that the supply was much smaller than the demand, which is a bad thing, because that means that essentially 22,000 people don't get this product that they really want, and you can't make any more because the producers aren't going to give you any more of them. So essentially what we really want to happen with supply and demand is we really want those numbers to be as close together as possible. That's the ideal situation, is at the equilibrium point, essentially, is that we've achieved equilibrium. We have as many items as we are going to sell. We don't have any left over. We don't have anybody who can't get the item. So we really want these numbers to be the same. So what this would tell us is we would want to increase the price, because if we look at these two situations, we see that with the supply, the larger the price, the higher the quantity is going to be. Whereas with the demand, the higher the price, the smaller the quantity is going to be. So we want to somehow make these closer together. So we want to increase supply but decrease demand, which would mean we want to increase the price. So that's where we were at from last time. So now we're asked, what is the equilibrium price? So the equilibrium price, remember, is where demand equals supply. So since these are both solved for Q, we can just set them equal to each other. There's one in your homework, I believe, where it's not solved for either variable, and you'll have to, well, there's a couple ways you could go about that one. But if you're struggling with it, you can just solve for one of the variables. I believe the x variable is the easier one to solve for in both cases. And once you have them both solved for one variable, you can set them equal to each other. So if we set these two guys equal to each other, we can add the 500 over the other side, get 1100p equals 33,000. Divide both sides by the 1100. That doesn't look like a 0. We get P is 30. So the equilibrium price is $30. And then the next thing we're asked for is the equilibrium quantity. Now, once you find one of the values, equilibrium price or equilibrium quantity, depending on the question, to find the other one, you're just going to take that value that you just found and plug it back into either supply or demand, because the point is that they're supposed to be equal at that point. So it doesn't matter which one you plug it into. So I would personally plug it into, which one was that? That was supply. I would personally plug it into supply just because it's the smaller equation. But if you plug it into demand, you'll get the same exact value, which will be 18,000. So break-even quantity is not a price. It's 18,000, and I don't think we're actually told what these are. Let me triple check. Yeah, we're not actually told what these items are, so I'll just say 18,000 units. So to achieve this equilibrium, they need to essentially set the price at $30, meaning that they will essentially produce and hopefully sell, because they're demanded, 18,000 units. So let me try to get this entire question in here real quick. Any questions, concerns on that question? All right, I'll wait a couple more seconds in case people are still writing stuff down. We've got one more question in this section. It's got a couple pieces to it. Also, this question, the first two parts of this question that we're about to do in a second, are very similar to the last question in your homework, question 21. And I did hope that we were going to get to this question on Friday, and it just didn't happen. I try to make all of the things get in by Friday, but it didn't happen. So this last question, you technically can do it, you just might not realize you can do it. So if we go to this one, we have that Anne-Marie's love of dogs inspired her to create the perfect dog biscuit, I can't read, and start up a business to share it with the world. Through market research, she found that at a price of $5, she was able to sell 10,100 biscuits, and that every decrease in price by 50 cents would increase the number of biscuits by 2,772. Assuming that this relationship between price and quantity is linear. Oh, sorry, I'm throwing things. What is the demand function Q in terms of the price P? So the first thing, we want the demand function in terms of the price. That means that we're going to have Q as a function of price. Okay, so on your homework, I believe it's always the quantity that acts as the X value, so it's always price in terms of quantity. But just look out for that phrasing to tell you which way it should land. And so if we want Q as a function of P, we have two things that we pull from this information. The first thing we have is that at a price of $5, she can sell 10,100, which means that our point would be 10,100. And now this is slightly different than the homework, because in the homework, they give you 2 points. Here, what they give us is a point and a slope. They actually tell us what the slope is. So in your homework, you'll have a second point and then have to find the slope. But here, we have every decrease in price by 50 cents would increase the number of biscuits sold. So let me erase the other things that I've already talked about so that it's only highlighting one thing. So a decrease in price of 50 cents would increase the number of biscuits sold by 27.72. Now, if we think about what the slope should be, since the slope is a change in y over change in x, in terms of our variables, that would be a change in Q over a change in P. So a change in quantity over a change in price. So if we read this, we actually are told a change in quantity. We're increasing the number of biscuits sold by 27.72. So our change in Q would be 27.72. And then we have a change in P, a change in price would be the decrease by 50 cents. So we're told that we have a decrease, so it's negative, of 50 cents. And this essentially is what sets up our slope for us. So sometimes you're not necessarily given 2 points, sometimes you're actually given the slope as words. This would come out to be negative 5,544. So here we have a slope, we have a point. We can now go to our y equals mx plus b format to find our b value. So we've got our y value, our q value here. Whoops, that I'm writing incorrectly. 10,100. equals M of 5544, X value of 5, P value in this case, plus B. Multiply that out, negative 5544 times 5. You have negative 27,720 plus B. Add the 27,000 thing over to the other side. You will get 37,820 as your B value. As always, I go through these calculations somewhat quickly because I trust and believe you could type it into a calculator. If you ever need me to slow down on those, just let me know. So our equation we're looking for is Q equals negative 5544, P plus 37,820. Oh, I should say that. One thing that happened on this last quiz that I didn't take points off on the quiz, but I will be picky on an exam. It's just like half a point, but I will be picky about that half a point. Is if your original question is given in terms of Q and P or T and S or whatever variables, make sure your final answer is in terms of those correct variables. Okay, so some people on the quiz on the P and Q question gave their answer as Y and X. And I accepted it on the quiz because you at least found the numbers correctly, but I would be picky and take off maybe half a point on an exam because you should really be putting that final answer in terms of the correct variables. If you want to do your work in terms of X and Y because that makes you happier, go right ahead. But just make sure your final answer is in terms of the correct variables for the question. Okay, so the next part, which is possibly the part that might have stumped you on the homework, because you might not realize that you know how to do it. So we're going to use that answer from part A to essentially get us the revenue function. So we want to express the total revenue she will make in terms of the price of each biscuit by substituting your answer from part A into the general equation for revenue, R equals P of Q. So remember that revenue is price times quantity. Whoops. And essentially what is happening here is we're going to take this Q and replace it with what we just found Q to be equal to. So we're going to have that revenue equals price times that equation. And then the last step you really should do is to distribute that P value through. So negative 5544 P squared plus 37,820 P. So Carissa, to just go back to your question real quick, be careful on web work if you haven't finished it yet, because web work uses X values instead of Q values. It's mainly because web work for some reason just really it's really hard to make it accept the value of Q as the answer. I don't know why. I've tried to write my own question and it doesn't work. So while those questions weren't written by me, I understand why it's a thing. For some reason, web work just does not like the variable Q. So just be careful there. Your answer will be in terms of X's instead of Q's. Also, the other thing about web work, I did send an email about this, but just to triple check that y'all recognize this, WebWork seems to require 3 decimal points to tell you that you're right, at least 3 decimal points, or you can leave it as a fraction. But if you round to 2 decimal points, it will tell you you're wrong, even if it's pretty much, you know, the right answer. You just rounded too much. I don't know how we were supposed to know that. Again, I think I've mentioned this a few times. This is my first semester officially using WebWork, so there might be a few of these little, not really bugs, but little things along the way that I don't realize are a thing. So that's a thing. 3 decimal places on WebWork to try to make sure that it registers your answers as correct. Okay. So, questions so far? Okay. So part C. To go global, she has a fixed cost of $10,000 and a marginal cost of $2 per biscuit. Express the cost C of producing Q biscuits. So we have C of Q, and we have the fixed cost plus variable cost. Sorry, marginal cost. Remember, those are the same thing. So we have our fixed cost of 10,000 plus our marginal cost of 2 times each amount of biscuits. So we have 10,000 plus 2Q for our cost function in terms of biscuits. I really spaced out these questions really much, and we didn't need them that spaced out. So the next part of the question is to then essentially take the equation we just found. So let me just, since it's no longer on the page, let me remind us the two things we're going to use here. We're going to take that equation we just wrote, and we're going to take our demand function, which I've already forgotten. So we're going to take those two equations and express the total cost in terms of the price. So notice that the cost equation we just wrote was in terms of Q. Now we want to change it over to be in terms of P. And since we know a relationship of Q equals this equation, we can replace that in. So we can have C of P. I'm going to change that equation now because we're changing the variable that's going to be, it's going to be in terms of. We'll have 10,000 plus 2 times essentially the demand equation, because that is what we know Q to be equal to. We should distribute that and simplify this a bit. So we have 10,000 minus 11,088 P plus 75,640. So that was from distributing that value of 2. So I could, but this is the answer to part C. So I'll just not scroll up and just tell you that that's the answer. That cost equation right there that I just highlighted is the answer to part C. And then if we combine together the two constant values, we will get 85,640 minus 11,088 P. So this is our somewhat new cost equation. Now the cost equation is in terms of price instead of quantity as it was in part C. So now we have the cost equation in terms of price. And to remind us, because we're going to need it in a second, we had the revenue in terms of price. That was our negative 5544 P squared. Those are this equation. So just to remind us of the other part we're going to need to use here. So essentially using that cost equation we just found and the revenue function we found before, let's express the total profit for her biscuit operation, if you will. So we're going to have profit in terms of price. Remember, that's going to be our revenue minus our cost. So we'll have the negative 5544 P squared plus 37,820 P minus, and then remember, always put your cost equation in parentheses or else you're going to simplify incorrectly. And then that 85,640 minus 11,088 P. I'll do an intermediate step here just in case. I would technically personally do 2 steps at once if I were doing this by hand, but let's distribute that negative. And now let's combine some things together. So the only thing we can combine together are the two terms that have P in it. The other two will have to stay separate. Negative 5544 P squared plus 48,908 P minus 85,640. So this is our profit equation. So this is the first nonlinear equations we've worked at. We technically haven't talked about these kinds of equations yet. These are quadratic equations. You've probably seen them before in your life, semi-familiar with them, hopefully. So they're our first kind of nonlinear function that we've really dealt with here. Questions so far on how I found any of those equations? Okay. As always, if you're already typing something out, keep typing it out. I'm not trying to stop you, but wait a couple seconds before we do this last piece to make sure everyone's caught up. Okay. Can I scroll? Jeez. So the last part, we want to use a calculator to graph the profit function that we just found and find the vertex. So since we're online, you can of course use websites. Well, I should be careful by saying websites because there are the two ones that I really allow you to use, quote unquote, because they're the ones that don't do more than I want them to do. So if I'm going to pull that up real quick, and it's going to make that look really silly for a second. Hold on one second. Let me, nope. I just want to remind you how you can do this if you're not familiar with it. If you have a handheld calculator and know how to use your handheld calculator and are comfortable with a handheld calculator, go right ahead. But remember, you can use Desmos. Love Desmos. It's great. I didn't select the D. Desmos. So Desmos. And if you wanted to graph this, we would essentially just type it in. 5544. We're going to use X though. It would probably handle, actually, what's going to happen if I put P? Yeah, it's gonna, yep. Use X and Y when you use Desmos. You can like force it to do it kind of, but it's gonna take more effort than it's worth. So we've got that graphed in there. So you can just literally just type it in and then you can hit this to make it go away. And then let's try to make, what's going on here? All right, so it's a very, oh, okay. Okay, that's not helpful at all. Let's try to do, let's go from -3 to, that doesn't look to go out very far. About 50. Less than that, 30. And then we're probably going to have to extend this up a ton. How about 5,000? Not enough? All right, cool. 10,000? Not enough. 15? 20? Almost there. 25? Haha, found it. All right, so sorry, I should have been doing that a bit slower. So if you're using Desmos and you can't just like scroll out to have it fit, because if you notice, I started scrolling out a bunch and it like disappeared because the setup. If you hit this little real wrench thing, you can also change the x-axis and y-axis that you actually want to look at. And you can also change a bunch of other things. But so the nice thing about Desmos is a lot of times it didn't really do it on this one. There we go. Once I clicked it, it did. When you click the graph, it kind of points out very nice points for you, all of the points of interest. So this one actually pulls out the vertex for us immediately. If you were to use, let me try to squeeze that over there really quick so I can make this a little bit bigger. So if you use a handheld calculator, let me try to remind us how we could do those. So if you have a handheld calculator, if you have a TI-84 or 85, 83, the way you would find the vertex is the first thing is you would have to figure out a window to actually get the graph in, which is going to be harder on the TI-83 or 84, I think, because you can't just, if you were to just zoom out, you would have the same problem that we just had on Desmos, and then it would take a lot more time to just keep guessing. But if you wanted to find the vertex on this, what you would do is you would use second and then the trace button. And you would select number 4 maximum. And then essentially what you do is you have to pick a point on the right of the maximum and then the left of the maximum. I think that's backwards. Left and then right and then guess the maximum. And then it'll tell you what it is. If you want more steps on that, let me know and I can try to show it to you a bit better than just explaining it like that. But also I think, especially just since we're online, having Desmos and just being able to pop over there is really super helpful. So Desmos is telling us that the vertex looks to be about 4.411 and then 22. How many twos are there? 224. And I'm just gonna say 02 because we're talking about a price here. So that was able to do it for us. One other thing I want to talk about really quick is if you were to do this algebraically, so if we have some ax squared plus bx plus c, finding the vertex algebraically, the x value is going to be always at the negative b over 2a value. So in our case, we would have had negative 48,908 divided by 2 times negative 5544, which, let me just triple check that it gets us what we need, but should get us what we need here. 2 times negative 5544. So if you put this in a calculator, you will get 4.41089 and so on and so forth, which is essentially what Desmos is giving us. It's just rounded. And then what you would have to do with this is you would have to plug this back in to get the other value. Anyway, so that was a lot of work. And what is the actual answer to this question? Kind of squeeze it in this box over here. So the actual question is, what price should Anne-Marie make each biscuit to maximize profit? Well, since this vertex is going to be the maximum, and the maximum occurred when the price was the 4.41. So she should charge $4.41 approximately to help maximize her profit. If you're curious, the maximum profit is at $22,224. But that's the answer to that question. Questions on that question? So since we're online, Desmos is an amazing graphing calculator site. It also has a scientific calculator as well. So you are always welcome to use Desmos if you'd like. Okay. Let me get this out of here and get back to just the notes. All right. Are there any questions about this section in general? Any questions? Yeah, that's what I meant on this section in general, because the last bit is our extra problems, which, you know, we don't go over it, but those will be on Blackboard if you want to look them over. Otherwise, we'll be moving on to our next set of notes. All right, I'll leave this up for like 5 more seconds. And also, if you want to grab the other set of notes real quick, if you don't have them already. While I'm waiting for that, let me babble a little bit. So the rest of your notes up to exam 1 are already up on Blackboard. The last section we might skip for time purposes, depending on how far we are in a little bit. But all of the notes that we will cover before exam 1 are up there. Your exam is coming up. Let me triple check that I'm not lying about the date. I believe it's on Wednesday, but let me triple check that. Not this coming Wednesday. Next Wednesday. Triple check that because I know one of them's on a Friday. Yep, nope. Wednesday, February 10th. So not this Wednesday. This Wednesday you have your normal quiz, but next Wednesday we have our first exam. So this week we will hopefully cover the rest of the material. We might need to take a little bit of time on Monday, but hopefully not. Because what I would like to do next Monday is I would like to just spend it on a review day. If we need to cover a tiny bit more material, we will. But hopefully we can cover the rest of the material on Wednesday and Friday, and then have Monday to review, and then Wednesday you'll take your exam. Exams are meant to be taken during class time. They shouldn't take more than class time. You know, since this is a synchronous class, it's almost like an in-person class, just not actually in person. But in terms of like how the assessments run, it's expected that you take them by the end of class and that kind of jazz. It's a 50-minute class. I'm going to give you a time limit of 60 minutes. What I usually do is I try to write an exam. I have like this process to try to figure out how long the exam will take for the quote unquote normal student. I will write approximately a 40-minute exam. You officially have 50 minutes, but I just give you that extra 10 minutes in case you need it. And that's the thing. On the exams, unlike the quizzes, the time limit is official. So after that 60 minutes is up, your exam disappears and anything you didn't get to is just you didn't get to, sorry. If you have extra time through the disabilities office, I'm just trying to say everything right now before we go on to our next set of notes. If you have extra time through the disabilities office, I should be setting that up for you on Blackboard. And if you open your exam and it says 60 minutes and not whatever it should say, close it immediately and let me know because it should have that extra time built in already. And I should be covering that, but try to triple check me if you are supposed to receive that. Anyway, I'll probably say all of that again, probably on Monday. So let's go ahead and get over to our next set of notes, which are exponential functions. So this is kind of our first official look at a nonlinear function. We just dealt with a quadratic, but now we're going to play around with exponential functions a lot. So I know this technically says warm up, but we're going to go through it together. So suppose you have $100 to deposit in a savings account. You put your money into Bank A. If you put your money into Bank A, they will deposit an additional $10 per year into your account. If you put your money in Bank B, they will increase your balance by 10% per year. How much money would you have after 1 year putting your money in Bank A? How much in Bank B? And then we're going to continue for a couple more sets of years. So let me like break this down the middle here. So for Bank A, if it's been 1 year, then you start with the essential, you start with $100 no matter which bank you put it into, right? And then if it's been 1 year, the only thing that's going to increase for Bank A is they're going to tack on an extra $10 into your bank, so you will have $110 in your bank account after year 1 in Bank A. For Bank B, you still start with that $100 to begin with, but then they're going to add on 10%. So it's going to be 10% off of that $100. So 10%, let me remind us, 10% is equivalent to the decimal 0.1. So if Bank B is increasing the balance by 10%, we're increasing it by 10% of 100. So this will give us 100 plus 10. So we will also have $110 after a year in Bank B. So far they're equivalent. Well, let's see what happens in the next year. So in the next year for Bank A, essentially the starting balance for that year is 110 because we're assuming you're not taking any out. You're just sticking it in there and leaving it for forever. So they're going to add on another $10 to that account. So after 2 years, you'll have $120. Whereas Bank B, your starting value again was 110, and they're going to add on 10% of that value. So 10% of that value is 11. So we'll have $121 in Bank B. So it's only a difference of $1, but Bank B is a little better right now. Well, what about 3 years? The beginning balance for the third year would be 120. Oh, yeah. Nope, just if there's ever a time where you can't see my screen, just let me know, and usually if I reshare. See it now? Great. Yeah, I can always easily reshare. So where was I? Third year, your beginning balance is the 120, and then they tack on an extra $10 at the end of the year. So we end up with $130 after 3 years in Bank A. And then Bank B, our starting value, why'd I suddenly switch to an equal sign? Starting value is 121. And then we're going to add on 10% of 121. Which is 12.1. So we'll have, $133.10 in Bank B. So now we're $3.10 ahead of Bank A. So if we wanted to know which bank should you use, I would hope we would all say Bank B. Because though it's not a significant amount of money at this point in time, it's getting us more money over the years. The first year was equivalent, but after that, Bank B won. And the farther we go out, the more years we tack onto this, the better Bank B is going to be. So what this is kind of doing is this is essentially giving us an introduction to exponential equations. Bank B is essentially following an exponential equation. It doesn't quite look like it. That's not what an exponential function looks like, but it's following the idea behind an exponential function. It's growing by a percent per year instead of just a set value. So some questions on that before we go over definitions? Cool. I'll try to leave that third one in there for a little bit. There we go. So a function p, we usually use p for exponential functions, is an exponential function of t with base a. So that's like the whole phrase. P is an exponential function of t with base a if it takes the following form. P equals p naught a to the t. Some other forms you might see this in. So this is the form that the Hughes Howlett book uses. If you're using the online book, it will have an a b to the x form. And this would be an exponential function, just to be super clear. Exponential of x with base b. So that'll be a tiny bit confusing if you're trying to go between the two books. So the base, just to be clear, the base, where do I want to write this? The base has the exponent. Okay. So it really doesn't matter. We're not really going to very much refer to it as base A or base B. Just know that when I say the word base, I mean it's the thing with the exponent attached to it. Okay. So I'm really just going to refer to it as base. I'm never going to really say base A or base B. So P naught, or A, if you're using the other one, is the initial value. I will always use P naught. Okay, so this is the form that I will always use. It is exactly the same thing as this form, just different letters. This is also sometimes called the initial condition. So initial value or initial condition. And the A value or the B value is the base. And again, I will never have to refer to base as a specific letter. I will just use the word base. The base is the thing with the exponent on it. So it's the base, and this is essentially, well, sorry, that should be in parentheses. So A is going to be, it's called the base. And what it is it's the factor that P changes by when T increases by 1. So it's called the base, but what it actually is the factor P changes by when T increases by 1. So essentially in the example we were just looking at, the base would end up being that 10%, that 0.1. Well, that's technically a lie. I'll talk about that in a second. I need to define something else before I can tell you why that's technically a lie. So if A is greater than 1, we have something called exponential growth. And if A is between 0 and 1, we're going to have exponential decay. Now notice that this does not account for negative A values. Negative A values, well, if you were to have something like this, technically the A value is not thought of as being attached to the A. You would never have an actual negative A value in an exponential function. It's kind of tacked on the outside. Well, technically, these are two things that you could see in your life. In terms of our class, we will never touch either of those. Okay, So we will never deal with negative A values in any fashion. So yes, technically you can have a negative A, but that's much more advanced and much more crazy things than we're going to deal with. So we are never going to deal with negative A values. Our A values are always going to be positive. And if it's greater than 1, it's growth, and if it's between 0 and 1, it's decay. Now A is equal to 1 plus R. Now I know this is a lot of information at once. So A is equal to 1 plus R. R is the can I read? R is the decimal representation of a percent change. So this is why I was slightly lying a second ago. That 0.1 in the problem we were just working on, that would have been the R value, not the A value. I misspoke. So it's essentially that percent change. So it would have been the 10% to give us the 0.1. If R is greater than 0, this is when we have our growth. And if R is less than 0, so R can be negative, but A will not be negative. We have exponential decay. So in this class, we explore these exponential functions in kind of their most useful form. If you ever try to have a negative A value or something like that, it's no longer really useful for context. So we're working on the most contextual types of problems, the one where A is positive. So yes, R can be negative. Let me just do a little side note. A will not be. And again, this is just in terms of our class. In general, you could have an exponential function where A is negative, but we will not deal with those. So don't go around telling everybody that A values can't be negative ever. They can be. Just, they're not useful to us. So for our case, R can be negative, but A will not be negative. The most common base is actually the number E. So E is actually a number that is approximately 2.71828. It continues on forever, just like pi. So we will never use E as a variable. If you ever see E in an equation or a question, it's the number. It's not a variable. Pretty much every mathematician has agreed to never use E as a variable. This is called the natural base. So that was a lot of information at once. Let's see, 5 minutes. Do we have time to do this first question? Yeah, we might as well start it. So if we have to come back to it at the beginning of next time, we can do that. So remember when we were talking about linear functions, we had a way. So your exam is going to cover chapter 1. Technically, chapter 1 goes up through 1.9. We might not get to 1.9. We're hopefully going to get all the way up to 1.8 at least, which is why we might need to take a little bit of Monday. 1.6 and 1.7 are pretty quick. So those should hopefully go by pretty quickly, and then we'll squeeze 1.8 in there. We'll probably have to skip 1.9. But no, there's a little bit more on your exam besides this. So a couple more sections. So we have a new restaurant just opened. The table below gives some values for f of t, the number of customers on day t. Could f of t be exponential? Why or why not? So again, I think I was saying before, we had a way to tell whether a table was linear. We did those little like loop-de-loops and figured out if the slope was constant. Here, what we need to check for is we need to check for something called a constant factor, a constant ratio. And I don't think we'll finish this, but I can start setting it up at least. We want a constant factor. And if the x, or in this case our t values, I should not. That's going to be confusing if I don't put or in there. If the x values or t values, whatever your independent variable is, are consecutive, you just divide the f of x, or f of t, or whatever the y values are. You just divide those values. So if we were to start trying to check for the constant factor, notice that between 1 and 2, they're consecutive. They increase by 1. So we would take their, I need to be careful here too. How do I want to phrase this? You always take the second y value first in the ratio. So it's always the y value of the larger x value first when we're doing these ratios. So we would do 18 divided by 4. This would be, my notes butchered that. So what is this? 18 divided by 14. Okay. So that's our first ratio. So we're going to keep that in our back pocket. From 2 to 3, that's another increase by 1. So we're going to take 24 divided by 18. It's always the y value of the larger x value on top. This is 1.3 repeating. Let me take one more really quick. So the next step from 3 to 4 is also a consecutive x value, so we can just divide their y values. We get this. Now I'm going to come back to this and talk about this more on Wednesday again, but notice how those numbers aren't the same. They're kind of close, but they're not the same. So this would not be exponential. The factor is not constant. So when we want to check if a set of data is exponential, we need to look at these factors of these y values. Now there's a bit more to it, and again, we're going to come back to that on Wednesday, but this is what we're looking for when we're looking for whether or not something is an exponential function. We're looking for a constant factor as opposed to a constant slope. And in this case, since we started looking at these factors and they weren't the same number, it wouldn't be exponential. So we're going to come back to that again on Wednesday. Let me type out what your quiz is going to be on really quick. Your quiz is pretty much going to be on cost, revenue, profit, and then supply and demand. So from both of these, there will also possibly be some break even or equilibrium points. I could ask you things like, what is the cost, revenue, and profit functions? I could ask you to find a demand function in terms of being linear. I could ask you for a break-even equilibrium point, so on and so forth. So yeah, answering your question, Sia, all of the factors, so all of these things that I just calculated out here, all of these would have to turn out to be the same number to be exponential. So those would have to turn out to be the same thing for this data to be exponential, exactly. All right, we're 1 minute over, so if you need to leave, feel free to peace out. If you have some questions, feel free to stick around a little bit. I've got some time. Otherwise, I will see you on Wednesday for your quiz. And we'll talk about this again. We'll talk about this a bit more on Wednesday.